Hey there, this is video U529. We are practicing more z-scores and we are finding values, not percent. So this is slightly different. Again, it's related to section 5.5 in your textbook. So let's get started. Athletes should replace their running shoes before their shoes lose the ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640 with a standard deviation of 160. Jack is an elite runner who wants to replace his shoes at a distance when only 25% of people would replace their shoes. At what distance should he replace his shoes? Okay. I don't know, but I do know that much. And that much tells me I need to draw a graph. I need to draw a normal distribution curve. There is my mu. Now, if anybody's worried, why is she drawing such a really big one? Mostly because I realize my numbers are fairly big and I don't want to have to turn my page sideways. Now, if you drew a nice little one and you have nice writing, perfect. So 640, and this is kilometers. So plus 160. All right, let's get our numbers in here. So it's 800. Be nice. Oops. 960. 1120. And the other way. Right. You guys should have got this much done without me. 640 minus 160. All right, so frequency and 0.15. Those are all percents. Okay. So Zach is an elite runner and wants to when only 25% of the people would replace their shoes. Well, how about let's look at it this way. If he replaced it at 640 kilometers, that would be when 50% of the population replaces their shoes. So it needs to be less than that. So we can guess, but you know what, actually, I need to do it backwards. This will probably make more sense. If he replaced his shoes there at 160, that would mean he would be replacing them before 0.15% of the population did. I want more than that. So if he goes up to 320, then it would be 0.15 plus 2.35. And that is a grand total, you should know by now, of 2.5. That's not enough. I want 25%. I can even add on the next 13.5%, and that gives us 16%, but I can't go here because that's going to be 50. So the 25%, I don't know, I'm going to guess it's somewhere in this range. And I want all the colored part back here. I'm going to highlight it. To be 25%. So I'm just going to do a quick estimate. So it needs to be more than 480. because at that point, only 16, because we add these up again, 16% of the population would have done it. Less than 640. Okay, because at that point, that would be 50% of the population. I guess I probably just could have said between 40 and 640. Oh well. All right. So we have a rough estimate where it should be. And we know it's going to be less than our standard deviation. All right, so here's the fun stuff. We got 25% of people. What we're doing now is we are pulling numbers off the Z-score table and we're converting them back to standard deviations. Oh, which should be less than, I don't want to write less. I was going to write less than -1 standard deviation, but that's going to get all weird. Let's just go with it, right? It's going to be negative. Whatever number we get is going to be less than 1, okay? Standard deviation. So I don't know what to do with this, but I know I'm going to do a Z-score. So my Z-score is equal to x minus x bar over sigma. This is my Z-score. No, it's not. Nope, nope, nope. This is from my table. All right, I'm going to get there in a minute. All right, so the 25%. It's funny when I started doing those videos, I'm like, I have to do them in pen so the students can see. And I'm like, not with these questions. All right, let me try that again. Okay, so 25% is from boxes on the table. So before we do anything else, we need to divide it by 100. So that's 0.25 on the table. So we need to look that up. So this is backwards to what we've been doing all along. We want to find 0.25. Use 0.25 in the boxes here. So my first is going to be 0.2. Oh, okay. Yeah. It'd be more helpful if you could see. All right, we got 0.24. That's not enough. There we go. Okay, 2451, 2483, and 2514. So we are looking for the number closest to 0.25. He wants to do it when it says about 25%. So I'm going to pick, I'm going to tell you how I'm going to do this. .25 minus 0.2483. That is 17 away from 0.25. Right, you see that? And if I go 25, whoopsies, 0.25 minus 0.2514, well, I know that's 14 away. And I hit the plus button there, sorry. So I'm going to use 2514. And that, if we read back this way, negative 0.6, and then we go 14, we go up, and 7. There we go. What I was doing there is I just wanted to see, like, we're looking for a number in between those two, and 0.25 is closer to this one than it is to that one. to negative 0.67 standard deviations. Now, before we go any further, does that match our picture, right? I'm a very visual learner, and that's why I'm doing that. So here was the 0. This would be 1 standard deviation is here at 480. So that makes sense. This is a reasonable answer. All right, now we can do our z-score. We don't need score. So this negative 0.67 goes here. It's a number from our table. So like we're kind of working backwards to what we usually do. Usually it's, we have a number, we find a z-score, we go to the table to get a percent. Well, now we're at the percent. We're going to the table. We're going to a z-score to get the value. So x is the number I don't know, right? Right? But remember, that's what we're trying to do. We're trying to find the number that fits there. Minus x bar r. The mean distance was 640 over sigma, which was 160. All right, so we need to solve that. A lot of ways. Easiest way, my world. Love cross multiplying. So 1 times x minus 640 is equal to negative 0.67 times 160. So x minus 640 is equal to negative 0.67 times 160, negative 107.2. Now I need to solve for x plus 640 plus 640 plus 640. 532.8 kilometers, because we were doing it in kilometers. And then again, I'm going back up to my picture. So we just said it's 532 kilometers, and we said it should be somewhere, it should be more than 480 and less than 640. And indeed, that number right there could be 532.8. Since it looks like my question here is going to the nearest whole number, we would go 533 kilometers. And I just realized that's not a capital K in kilometer. Sorry to make that look weird. Okay, so there we go. Oh, true replacement. Ta-da! Okay, so basically the questions are either you're given a value, you find a z-score, use the table to find a percent, or like this one, you're given a percent, and then you go to your table and you find your z-score and you find the number that fits there. And that's the end of the video. Have a great day.